Hello, my name is Joshua Fair. I'm currently taking Physics 2212 at Georgia Tech, and this is my lab video. This lab discusses the lines of charge activity and electric force and magnitude. Introduction and models. Now, this lab discusses four key topics. The first being Coulomb's law, which explains the electric force of attraction or repulsion between two stationary objects, followed by gravitational force, which deals with the force applied from one object to another in terms of gravity, then followed by Newton's third law, which states for an action, there is an opposite and equal reaction, which would be relevant when dealing with the floating tapes. And finally, vectors, which are arrows that indicate magnitude and direction. All of these are supported by superposition, which relates to dividing a charged object into sections. Overall, these topics will be used when discussing the overall purpose of a lab, being to distribute charges evenly across a tape to determine electric and gravitational force. As you can see on this slide, it shows the formulas for each of the four key topics, which will be used later to calculate the values and in the code. And in addition to gravitational force, the electric force formula is also shown as well. Now, like I said before, the purpose of this lab was to use tape and distribute charges evenly across them. Now, in addition to this, we took two pieces of tape and we tried to see if they repel or attract one another long enough for one to float. As you can see on the model on the side, the tape over here is floating as the other tape below it is pushing it up. The system is the tapes and the surroundings are the air and the placemat. In addition to this, you're also seeing a general overview of results for the lab experiment itself, with the key data being recorded. The charge on each piece of tape will be calculated later in the code. Now moving on to the experimental model, which is from the first part of a lab and is a recap. Now the steps of the experiment were to determine the charge of one tape and then to float one tape above another to see which had a resulting repulsing force. From this experiment, my group was able to observe the tapes 1 and 2 repelled each other. The tape and the pen attracted each other, and the pen attracted the tape. Now the experimental data we got from this lab 1 is shown here as well. Take key note to the fact gravitational force and electric force are reverse of one another. This deals with Newton's third law. Now moving on to part 2 of the lab, which was the coding section. Now the code itself included various formulas from before and has the initial conditions of the experiment listed here under physical constants. The assumptions for the code are also listed. Air resistance is ignored. Treat a long tape as a point charge, and each U tape had the same charge. In addition, the magnitude of the charge of one piece is shown that will be calculated later from the code. Now, as you see here, the code calculates the electric field formula into a definition formula and returns it later. Now, this next line of code shows the line charge formula and the division of the tape into different components, as you can see here. In addition, the arrows are all starting to be created with the top tape and the bottom tape. Our last line of code, the last section of code, shows a nested for loop and demonstrates superposition and scale to calculate the electric force, as you can see here in the nested for loop. This essentially takes it, puts it into a formula, and spits it back out right here, which creates the arrow for the net electric field. Now, this is the final model that the computational code produced. The red and blue charges themselves aren't present, and this is likely due to an error in the code or due to the math somewhere in the code which led to them being too small, probably a scaling issue. The electric force and gravitational force are also shown. However, both numbers are too large and should be inverses of one another, Newton's third law. This is also, again, likely due to a math error in the code. Overall, however, this model using the tape, evenly distributing the charges, is more accurate than the previous model as a single point charge. Discussion and conclusion. So what if you had modeled each of your tapes as a single point charge like in the previous lab compared to the estimated value of the charge you get and the experimental value? Well, as you see here, the difference is quite large at 101%. And this definitely means that the line charge that we did in this lab is more accurate than a single point charge by far. And what does it mean? Do these estimates differ? And which value is more likely to be closer to the real value and why? Like I said before, the line charge is more likely to be closer to the real value, as you can see by the large difference. And this is due to the fact the line charge more closely demonstrates superposition, which means the value would be more accurate to what it actually should be.